Analyzing the time series forecast. 6. Manually stretch the new window and click on the Simulate Animated Profile button. When this animation button is turned on, it allows you to see several iterated pathways, marked with the red line, on the forecast band to the right-hand side of the chart. This option is analogous to the dice icon being turned on, which allows you to see different random representations of the pathway of prices on a pre-simulation environment by recalculating with the F9 keystroke. It is as though, at every single change on the red pathway, we are forcing the software to generate different pathways the gold price might eventually take. Notice that the shaded forecast assumes a central black line with a mean, then a dark gray inner band depicting percentiles 25 and 75, that is, the interquartile band. Finally, a light gray band with the 5th and 95th percentiles. By leaving the red pathway on animated mode enough time, approximately 5% of the time this red pathway will exceed the 95th percentile, and on 5% of the time this red pathway will be under the 5th percentile. You can change these charting parameters at any time by right-clicking on any part of the chart and selecting the first option, Graph Options. We will not change any charting parameters at this time. Observe on the left-hand side of the window that MA1, that is, a moving average of first order, has been chosen as the best method to fit your historic data, according to the AIC criterion. If, at this point, you select the second best method, an R2, that is, a second-order autoregressive process, you will see how the projected pathway of probabilistic prices changes slightly. 7. Click on Other processes suggested on the list and observe how the projected pathways change. In this case, you can observe that variations from one method to another are near insignificant. In fact, the AIC statistic coefficient seems to stay a relatively similar number. 8. Go back to the first method on top of the list, the MA1, and click the Write to Cells button. At this point, At Risk will select a predefined range of 24 cells down, exactly for the range going to December 2020. This is purely coincidental, since the default number of cells to forecast matches the number of months for which we want to forecast gold prices. If you want, you can extend or limit the range size to place this array function. 9. Click OK. At this moment, At Risk will place array formulas on each one of the cells for the selected range. You will know these are array formulas because they are nested by brackets. An array formula cannot be changed individually. Any change on a given cell of an array range has to be done to the whole range as a single entity. 10. On top of cell C261, press F2 to observe the syntax of this function on edit mode. 11. If you want to obtain a better understanding of the nature of each parameter in the formula, simply click on the FX, Insert function on Excel's formula bar. At Risk will open the editing window of a formula. By shifting to each one of the parameter segments, you will be able to read a description of each one of the parameters. 12. Click Help in this function text, located on the lower left-hand side of the window to get further detailed information of what the formula does and how it is calculated. 13. Close this help window and exit the editing mode for this cell. 14. Make sure the random/static standard recalc button is on. Now press the F9/recalculation button several times to observe how the values on this 24-cell range change as manual iterations are being generated. Each time you press F9, At Risk is generating different random pathways for the price of gold, considering a moving average of first-order process as it has been formulated here. 15. Make sure your iteration number has been selected to 5000 and proceed to start a simulation. Once the simulation has finished, there are several ways to evaluate the pathway for gold prices created by the simulation process. Remember, we have not defined output variables yet. Gold prices are still only input variables, due to change during the simulation process. In that sense, the model is still incomplete.